Advent of Code 2024, Day 6. We have a grid with obstacles, along with a single guard patrolling it. The guard's movement is completely determined by these obstacles. Initially, she moves up, but as soon as she encounters an obstacle, she rotates clockwise by 90 degrees. For part 1, we want to know how many different cells she visits until leaving the grid entirely. Let's first write a convenient vec2 class, which will simply store 2 integer coordinates. Because we have a finite grid, it is convenient to use an RC system rather than an XY system, which means that the origin is in the top left corner and moving down corresponds to increasing the first coordinate rather than decreasing the second one. After once scanning through the grid to find the location of the guard, we can start simulating her walk. The implementation is pretty straightforward. To do a 90-degree clockwise rotation, we simply swap the direction coordinates and negate the second one. We use a set to collect each visited cell so that we avoid double counting. In the end, we just print out its size and we're done. For part 2, we are allowed to strategically place one additional obstacle in order to cause the guard to enter an infinite loop. We want to figure out in how many different ways this can be done. Naively, we can iterate over all of the visited cells we collected for part 1, artificially insert the new obstacle, and rerun the simulation, paying attention once a cell is visited twice with the same facing direction. This works, but it takes up to 45 seconds on my machine. There are 2 immediate improvements. First, we can place the extra obstacles while solving part 1, which avoids needlessly repeating the initial steps until that particular cell is reached for the first time. And this saves us 30 seconds already. Second, we can skip directly from obstacle to obstacle rather than walking one step at a time. To implement this, I created a highway dictionary after reading the input. For each non-obstacle cell and direction, it points to the next obstacle in that direction, or none if there isn't one. When skipping, you have to separately handle the extra obstacle which is not included in the highway. With these improvements, I could get the runtime to under a second on my machine. Can you think of a better solution? Let me know in the comments.